Next topic is energy of a system. The best definition of energy is the ability of a system to produce work. So this definition is not always apprehendable because not always the fate of energy is to produce work. Therefore, there are possible that one kind of energy is transformed into another kind of energy. The final result may not be work. The best way to apprehend the concept of energy is to show that energy can be produced with the help of work. If a system, or if we do an external, we or external agency do some work against a conservative force of a system, then what happens? An energy is stored on the system. What is conservative force? Like the force regarding compressibility or expandability of a gas, the elastic force of a rubber or a spring, the Coulomb force between two charged particle. Why they are called conservative? Because if you want to change the configuration of them, then it will want to come back to its initial position. Like if you compress a gas, then it will try to come back to its original position. If you elongate a spring, then it will try to come back to its initial position. That's why they are called conservative force. So if someone does work against those conservative force, then what will happen? Some energy will be stored on the system. And when the gravitational force is also a conservative force. So for it, then how can I show that a system gets some energy with the help of work? Now if you take a ball from a metal ball from downstairs to first floor of a building, then what will happen? You are doing some work against the conservative gravitational field, so some gravitational energy is stored on the ball. Now what will happen? That system now has got some energy. Now that system has the ability to do some work. If you throw the ball, with the help of the ball you can get some work from the system. So that is how energy is, we can produce energy with the help of doing some work. This is actually the concept of energy. Again, you see, when we do, how we do that work, we see any mechanical work, if you want to do, what we do actually, we, in case of a human person, what we do when we take the ball from first floor to second floor, so what is happen? The chemical energy inside our body produce energy. That energy, chemical energy, is actually converted to work. That work is converted to the gravitational energy. Now you see, the work is actually a tools in between two energy state, from chemical energy state to the gravitational energy state. The work is a tool, an instrument, or we can say a machine. So in this way, work we can say is a energy in transit. So work in no system has any stored work like that. So what happens from one energy is converted to another energy. It happens either through work, and in next topic we will come to heat, or through heat. These are the two instruments which actually we can say is energy in transit. They actually, this kind of energy, heat and work, they are actually not stored inside a system. They are always are in transition in between two energy states. Next we will come to the concept of heat. Heat is also a form of energy because it can yield work, or it can be produced from work. Like work, heat is also an energy in transit. So what is the difference between work and heat? Heat has a sole identifier called temperature, which is itself a manifestation of increased translational, rotational, vibrational motion of the constituent particles of the system. When two conducting bodies at different temperature comes in contact, then what happens? The energy in the form of heat flows from one body to another body until they obtain same temperature. At equilibrium, when the energy flow ceases, we then cannot speak about the presence of heat in any of the body. Only during the process of flow of energy we can comprehend heat. When heat flow ceases, we cannot speak of the presence of heat in a body. Heat in a body is always meaningless. What may be present in the body is some other kind of energy, like we earlier says that translational, rotational, vibrational energy, like this. Obviously not heat. That is why we say that heat is energy in transit.